Okay, good morning everybody. First of all, thank you for taking the time to watch this. I'm going to try to make it as brief as possible. I know whoever's watching this is probably very busy, and so I'm just gonna try to make my case here and make it as brief as possible. This is my artificial light and evacuated tube boiler. All these evacuated tubes, there's 1, 2, 3, 4, 5, 6, 7, 8 evacuated tubes, solar evacuated tubes. 1, 2, 3, 4, 5, 6, 250 watt light bulbs. In this case, halogen light bulbs. 6 250 watt. The idea was to, these are very common. I'm sure anyone who is watching this video is aware of these. They're intended for outdoor use. They're intended to collect solar energy, and it's basically the same idea as the outdoor solar energy collectors. They all adjoin a common header. They heat water or some type of fluid inside the tubes, which in turn heats some kind of fluid that's in the common header, which in turn heats some kind of fluid that goes to wherever it is that they want the heated fluid to go to. In this case, I'm going to send it to a coil. The only difference is that I brought it inside, and I put some, instead of collecting sunlight, they're going to collect artificial light via these halogen light bulbs. This particular test that I'm doing here is 1500 watts total. I'm no expert by any means, but I would imagine that is low enough wattage to still use solar energy via solar panels. It's basically the amount of, it's the same amount of wattage used from a space heater. So, I do want to show you, this is patented. Let me turn this off real quick. Sorry about that. Issue date is January 2nd, 2018. I was given a 1,003 day adjustment. It's not very focused. I hope you can see that. It took them 1,003 days to figure out what they wanted to do with it. They finally decided to issue the patent. My name is Brian Dunn. I live in St. Louis, Missouri. There's the patent number, 9857097. My phone number is 314-771-6001. If you're interested, give me a call. I work ridiculous hours. That means I sleep ridiculous hours. I may not answer. Just leave a message. My email is bmmd23@yahoo.com. bmmd23@yahoo.com. The number 23, 23. There is a direct correlation between the amount of wattage coming from the light bulbs as to the amount of heat that is produced. I did another test with 100 watt light bulbs, and it produced, I don't want to say significantly less, well, okay, yeah, it was significantly less heat. I think it maxed out at, I can't remember offhand, 130, 150 degrees, something like that. But I'm going to show you the 250 watt. I'm going to do two tests. A static test, where there's no flow. This pump will be turned off. I turn it on by just connecting the wires. So the wires are disconnected. These valves are closed. The valves on the coil will be closed. So it'll just be a static test. I'm just going to show you what it does just sitting idle and just creating heat. And then I'm going to open all these valves. I'm going to open these back up and turn on the pump. The pump will pump, in this case, water. Through this bulkhead fitting. I have an aluminum line that looks kind of like this inside the header. This flange right here is the same as this flange here. It just coils to the back of the header, loops over, and then coils back to the front of the header and leaves through this bulkhead fitting. We'll go down to this manifold. It'll leave the manifold here, enter the coil, loop through the coil, loop over to this side of the coil, and then back to the manifold, and then back to the pump, and then back to the boiler. So that'll be the second test. So let's just get started here. Current temperature in the header is 60 degrees. Looks like it's 60 degrees right on the money, 0 psi. I'm just going to do 1 hour intervals. Show you what it does after an hour. Push pause, come back an hour later. So there it is, all lit up. It's pretty simple. It's a pretty simple design, nothing fancy. Light bulbs and vacuum tubes, that's it. And a pump. And someplace to take the heated water too. It's 8 a.m. I'll be back in an hour. 8 a.m. 60 degrees. I'll be back in an hour. Okay. Oh, I'm a little bit early. I thought it was 9 o'clock. It's about 4 minutes till 9. So almost an hour. 130 degrees. I have this pressure valve all the way open. So it shouldn't, the PSI should not come off of 0. And some of my, I've done earlier tests, and the temperature does achieve a higher temperature when there's some pressure inside the boiler, up to about 5 pounds. I got it up to about 10 pounds one time, and it blew one of the vacuum tubes off of this coupling. It just sucked the vacuum tube right out of that coupling. These are just rubber boot couplings with an aluminum wrap around them, adjoining the vacuum tube to these 2-inch stubs I have welded to the bottom of this aluminum rectangle. Something else I need to mention real quick before I forget. I am not a lawyer. My attorney took care of all the patent stuff. he wrote to me in an email, and I read through the claims. You know, the claims are the meat and potatoes of any, in the eyes of the law. When you're looking at patent stuff, you look at the claims. I believe that this boiler, the patent covers any artificial light source. I happen to be using halogens. Halogens are the only thing that I had success with. But who knows what's out there that I did not try. But as far as I know, I believe that the patent covers any artificial light source. So before I forget, I just wanted to mention that. I think that's one of the more interesting aspects of this whole thing. So anyway, it's been an hour, 110, 20, 130, a little over 130 degrees. I believe we started at 60, was it? So 70-degree rise in an hour. I will be back in 1 hour. Okay. 10 o'clock, an hour later. And 190 degrees. Zero psi. Like I said, I've got this little pressure relief valve wide open. I'm kind of tempted to get a little bit of pressure on it. I know the max temperature raises, the maximum temperature is a little bit higher when there's a couple pounds of pressure in it. But anyway, there we go, 190 degrees, 2 hours total. I'll be back in an hour. Okay, this is an hour later, 11 a.m., 3 hours total. Just a hair under 230 degrees. Call it 229. You can hear the pressure coming out of this. I don't know if you can hear that or not. It's really boiling inside there. I came down here about 15 minutes ago and this fitting had pushed out. I pressed it back in. I don't know what's going to happen when I turn the pump on. But I've had all kinds of little problems. This is just a cheap plastic fitting I got on the internet. Little bulkhead fitting. And there's an insert inside this threaded part. And that insert pushed out. So I don't know what's going to happen when I turn this pump on. But I'm gonna keep relieving this pressure a little bit. And I'm going to give this another, probably at least, I'm just going to try to give it another hour, see what we can get this temperature up to. But I'm going to come down here and check on it every 10 or 15 minutes, see what happens. So at a minimum, I'll be back in an hour. Okay, this is 40 minutes later, and this is not budged. It may have come up 2 or 3 degrees, 220-ish. So before I got this little pressure relief valve, I just had here it is right here. I had just this solid plug that I had in this threaded fitting, and when that solid plug was in there, this temperature almost got to 250. But like I said, the PSI, I think the PSI made it up to about 10 or 12 pounds when it blew off one of the vacuum tubes. So that little fitting definitely helps relieve the pressure, but the temperature doesn't get quite as high without some pressure in it. So anyway, what I'm going to do is I'm going to turn on this pump, and I'm going to run the water that's in this coil. I'm going to run it through this system. The water that's in this coil is ambient air temperature. It should be exactly what was in here when I first started, which was, if I remember right, it was 60 degrees ish. So let me open these valves. See, it's already letting cool. I don't know if you can hear that or not, but as soon as I let that cool water surge, or let the heated water out, one of the two, open these up. Turn on the pump. This is the water coming from the boiler going to the coil. Boy, that's really, I don't know if you can see that. I'm probably shaking as much as it is, but this thing is when you add that cool water to that hot water, it really starts jumping. So anyway, this temperature is falling. This is increasing. This one's coming from the coil back to the boiler. It hasn't worked its way through there yet. It should. Yeah, that's starting to, it should be working its way through. Wish this phone would focus a little bit better. You can see it starting to come up now. It's at 140-ish, coming from the boiler, coming from the coil. It's just reached 100. So anyway, you get the idea of what's going on here. I'm circulating the water. The water that's in this coil it's separate from the water that's in here, but it's picking up the heated water. The heat in this header is transferring to the water that's in this tube. So they're separate bodies of water, but the pump is picking up the heated water that's in this header. So it's 1:45 to noon. I'm just going to let this run. I'll do the same thing. I'll do hourly checks. I'll come down in an hour. I'll show you what these gauges are at. That's primarily, that's where the focus should be, because that's the temperature. That's the circulating temperature. And the header. We'll pay attention to that too. So I'll be back in an hour. Okay, this is an hour later. 1 hour after turning on the pump. Header temperature is 135. Coming from the header and to the coil, 120, maybe 121, and then coming from the coil back to the pump, a degree or two different. 119, yeah, it looks like about 119, 118, 119. Before I forget, I want to mention I have not, remember there's 6 250 watt light bulbs. I have not tried something like 4 500 watt light bulbs or 6 500 watt light bulbs. To do that, you would need different size sockets. Where'd that? These bulbs are like 3 1/8 inch long. So I bought the sockets appropriate for these to go up in wattage. As far as I know, I've done a little bit of homework. I tried to find 500 watt bulbs that were the same length as these, and I couldn't. So to go up in wattage, you would have to get different sockets. I don't know if I want to. I'm going to let this go for another hour, so I'm not going to unplug it. Boy, that's really bright. I'll show you those sockets. I'm going to let this go for one more hour. I don't think much is going to change, but we'll see. And I'll show you those sockets. But that's, there's all kinds of variables in this thing. The amount of water that's in the header. With this test, it was about, I filled the water, it was about, you fill all the entirety of all of the evacuated tubes, plus I think I filled about 3/4 of the way up the header. You get different results if you only fill all the tubes about 3/4 of the way full and leave the remainder and the header empty. Then your temperature rise is a lot faster, but it doesn't climb quite as high. This is like an A style coil. These are actually these are two separate flat coils that I tied together. I soldered this fitting on so it would go from one coil to the other and then back to the pump. But they were originally intended to go in and then right back out. So, that's a variable. But the wattage of the light bulbs is probably the biggest variable that would make the biggest difference that I haven't tried. Putting in 6 500 watt bulbs, yeah, you'd be doubling your wattage. You'd be doing, it'd be 3,000 watts. But that would be a lot less than, like my furnace. I have an electric furnace. I think the heating element in that thing it's like 9 or 10 kilowatts. That's 3 times the wattage. So anyway, I'll be back, and I'm gonna let this go for 1 more hour. We'll see if these temperatures move at all. These were about 120, and the header was about 135. I'll be back in an hour. Okay, it's an hour later. 2 hours total with the pump running and feeding through the double coil back to the boiler. Temperature 1, it may have come down a degree or 2. I think it was 135 last time. It might be 134. So that hasn't changed. This has dropped a little bit more. Oh no, we did this one first. Yeah, this dropped. I think this was like 121-ish. Now it's 119. So this looks, I think this may have dropped a degree or 2 or 3, somewhere around there. And this is about the same thing. I think this was like, this one might be about the same. I think the last one was 119. This looks like it might be 118. That doesn't focus at all, does it? Well, how do you get that to focus? Well, anyway, you have to take my word for it. It says 118. I think it's probably dropped a degree or 2. So anyway, I think you get the idea of what's going on here. It's not rocket surgery. So anyway, again, my name is Brian Dunn. My phone number is 314-771-6001. My email is bmmd23@yahoo.com. I'm not an engineer. If you put an engineer, somebody with some brains and some math skills or whatever on this thing, maybe you can squeeze a consistent 180 degrees out of it. I think that's what most hydronic boilers usually push to a coil like that. Somewhere around 160, 180. This one's doing 120, so it's close. More light bulbs, do 2 of them in sequence. More wattage. Upsize, downsize, work out some kinks, try to get some more temperature out of it. But it's pretty, again, this is 1,500 watts total. 6 250 watt light bulbs. So if you're interested, just give me a call. I work crazy hours, so I sleep crazy hours. So if you call, leave a message. I would probably prefer that because, email may go to spam. I don't check my spam. But either way, email me. Hopefully I get any messages sent my way. But calling and leaving a short message, a contact number or whatever, would probably be the best. So thanks a lot for watching. I appreciate it, and have a great day.